In this video, we will be looking at 4.4, parallel and perpendicular lines. So, our essential question today is, how do I write equations of parallel and perpendicular lines? How do I write equations of parallel and perpendicular lines? Okay, so let's define parallel lines, and then we'll talk about how we can look at an equation to know if they're parallel. So, parallel lines are lines that never intersect. So let's say we label these lines A, B, and C. Lines A and B are parallel. They never intersect. And one way we could write that is A is parallel to, that's what this symbol is going to mean, is parallel to B. So we read this as A is parallel to B. Okay, but the one thing, and this how this ties back into lines and slopes and equations, is when you look at the two lines, when you look at A and B, what about them is the same? Well, they don't have similar y-intercepts. Those are very much different. But they do have, when we think of our like y equals mx plus b, they don't have the same y-intercept, but they do have the same slope. I can go up 3 and over 2. So the slope for b would be 3 over 2. And the slope for a would be, say I'm starting at this point, I'd go up 3 and over 2. So the slope for a would be m equals 3 over 2. So that is the big thing that we can take away. Parallel lines have the same slope. So their slopes are identical in value. Now perpendicular lines do intersect, but they intersect at a very special angle. So perpendicular lines are lines that intersect at a 90-degree angle. And the way we notate that is we would say A is perpendicular to, so it kind of looks like two lines meeting at a perpendicular angle, perpendicular to C. So I read this as A is perpendicular to C. Now let's discuss so it's really slope that is our big piece that we're looking at to discuss if they're parallel or perpendicular. So let's look at the slope of line C and see if we can make a decision about the slopes. So if I go from this point and I go to this point, so I'm going to go down 2. So my slope will be -2. So I went down 2 and then I go over 3. 1, 2, 3. So -2 over 3. So when I look at these values of the slope of A was 3 over 2, and the slope of C was -2 over 3. What's that relationship between those two slopes? Well, they have opposite signs. And I cannot stress this word "and" enough, because "and" means both of these parts must be true. So opposite signs and reciprocals. So we need both to be true. If it's just one, if it's just opposite signs, these are not perpendicular lines. If they're just reciprocals, but they have the same sign, so say they're one's 3/2 and the other's 2/3, they're both positive, but they are reciprocals, they're still not perpendicular lines. You need both parts to be true. Opposite, one's positive, one's negative, and they need to be reciprocals or flipped of each other. So let's look at some equations and see if we can identify if they're parallel, perpendicular, or neither. And all we're doing is looking for the slope. So the key point for this is just to find that coefficient of x, the number sitting right next to x, and decide, is it the same? Is it opposite and reciprocal? Or are they just didn't fall under either one of these rules? So if it's the same, it's parallel. Opposite and reciprocal, perpendicular. Or if it's not neither one of these, then it's neither. So I'm just looking for my coefficient. So I got 2 and I got 2. Is 2 the same as 2? It certainly is. So we can say these are parallel. Let's look at C. I have -4 and -1/4. Now I do have reciprocals, 4 and 1/4, but they're not opposite one another. One's negative and the other's negative. So this would be neither. Let's look at letter D. 2/3, -3 over 2. Remember, I'm always looking at the number that's directly attached to my x, my coefficient of x. And we have opposite, 2/3 and -3/2. They're opposite, positive and negative, and they're reciprocals. So we have both. We have satisfied both opposite and reciprocals. So if we satisfied both, then we can say that they are perpendicular. Now let's look at letter F. Well, I do have opposite signs. One's positive, one's negative. But are they reciprocals of each other? No, they're not. So unfortunately, what we have to do is say neither. Letter H. Well, it's hard to make a decision on exactly what the slope is until we solve for y. So you want to get your y equals, then you can identify the slope. So we have a little bit of math to do, and then we'll see what we get. So I'll subtract 3x from both sides on this one, and I get y is equal to -3x plus 5. Okay, so I have solved for y, and I know what my slope is, -3. So let's look at my other equation. Well, there's nothing to subtract over. All I have to do is get y by itself. And since it's 6 times y, How will I get rid of that 6? We'll divide. So I'll divide both sides by 6, and I get y is equal to 1/3 x. Okay, I only care about the slopes, so I'm just looking at these coefficients next to the x. Are they opposite each other? One's negative, one's positive. Are they reciprocals? That might be kind of tough to see unless we write in our hidden 1. So let's write in that hidden 1. Now I see that my slope is -3/1 and a positive 1/3. They are opposite and they are reciprocals. So we can say that they are perpendicular. Okay, at this point I'd like you to pause. Go ahead and try B through I and see if we can come up with these same ideas. Okay, so hopefully you tried B through I. We're going to move through this kind of quick. So when I look at B, I see that they are opposite, and if we write in our hidden 1, they are reciprocals, perpendicular. Now I'm going to use my shorthand to kind of move through this faster. Perpendicular looks like an upside down T, and parallel will look like just those two straight lines next to each other, kind of like an oversized 11. Okay, let's look at this. I have 5 and 5. Those are the exact same value, same sign, same number, so we can say that those are parallel. When I look at 3.5 and 5.3, while they are opposite, switching the numbers in a decimal does not make them reciprocals. We need to see fractions that are actually flipped. So this would be neither. Let's look at letter Y. Our familiar 1/3 and -3. Common looking slope in this section it's looking like. Well, are they opposite each other? One's positive, one's negative. So they are opposite. And are they reciprocals? One is 1/3 and one is 3/1. So we are opposite and reciprocal. So we'll call it perpendicular. Letter I. We want to solve for y, so let's look at subtracting x from both sides. So I get y equals -x plus 1. Hopefully we can see that the slope m is equal to -1/1. Now let's look at our second problem, and I will subtract x from both sides. And I get -y is equal to -x plus 4. Well, how am I going to deal with this negative in front of y? Well, if you remember, we have that hidden 1 in there. Let's write in our hidden 1. And so we're going to divide equal opportunity dividers. We'll divide everything by that -1. And now we get y equals +x minus 4. So my slope will be equal to 1/1. This one is a little tricky. Are we opposite? We are. One's negative, one's positive. And if I flip them, are they flipped of each other? Well, 1/1 flipped is still 1/1, so they are reciprocals, so we can say they are perpendicular. Okay, we're going to skip J and K. It's just a little bit more solve for y, then identify the slope. But what I want to do is go to the back and just do one problem so you have an example on the back of how we can build an equation of a line. Maybe two problems so we can see a parallel and a perpendicular. So if I want to write an equation parallel to y equals 2x minus 3 that passes through 3, -7, I cannot stress this enough. The quickest way to do this is to use our point slope form. And I'll explain why right in a second. So first let's identify it's a parallel line. So we know our slope, our given slope is 2. So what's the slope of our parallel line going to be? Well, slope of parallel line is going to be the same. So it'll be is m equals 2. Okay, so we found the slope we'll use based on our given slope. And now we need to create an equation of a line that has this slope and 3, -7. So we're going to use this point and this slope. Well, let's see. What equation needs only a slope and only a point? Use the words. A point and a slope is our point-slope form. So let's review what that is. We have our y minus y1 equals m times x minus x1. We plug everything in and we're done. So I have y minus y1. Let's go ahead and label up here x1, y1. So I can say y minus y1, which is going to be -7, is equal to slope 2 times x minus x1. And let's clean it up because we don't like minus and minus, so we'll say y plus 7 equals 2 times x minus 3, and we're done. Let's do one more example so you have an example of how to write an equation of a parallel line, and now I want to write an equation of a perpendicular line. Let's do the more difficult one so you have an example of something that's a little more difficult. So let's do letter D for perpendicular line. We're looking for perpendicular, so first we need to find the slope. Is the slope clear right here? It's not. We got to see what y equals first. So let's do our solve for y. So I got to start over here. 2x plus 6y equals 12. So our first step is step 1. Find the slope by solving for y. So let's find the slope by solving for y. I'm going to try to get y by itself, so I'll subtract 2x, and I have 6y equals -2x plus 12. Equal opportunity dividers, everyone gets divided. We'll have y equals -2 over 6 simplified is -1 over 3x plus 2. Okay, so if my given slope is, so I see that my slope is m equals -3. So the slope to my perpendicular line, or my perpendicular slope, will be, let's write it next to it. I'm sorry. Let's write it down here. My perpendicular slope is m equals opposite. So opposite of a negative will be positive, and flipped, 3 over 1. So positive 3 over 1. Okay, so we have our slope that we're going to use to build our equation, and we have our point up here, which is our x1, y1 right here. Now we just plug into our equation. We're going to use that same equation. I'm going to write our general form again. The more we write it, the more we practice it, the more it'll be stuck in our brain. Plug everything in, and we get y minus y1 is 0 is equal to m is 3 over 1, coming from right here, times x. Did I do a minus plus here? Sorry about that. I wrote our wrong equation to begin with. It's y minus y1 equals m parentheses x minus x1 parentheses. My apologies. So let's start again. Y minus y1 is 0 equals our slope, which is 3 over 1, parentheses x minus x1 is 5, And then to clean this up, I can get rid of the minus 0 because y minus 0 is still y. And we can turn this into a whole number. So we have y equals 3 times x minus 5. And that is the equation of our line. So we found the slope. Find the slope by solving for y was our first step. Then our second step was identify the perpendicular slope. That's what we did second, where I said, well, if I know my slope from my solving for y is negative 1/3, then my perpendicular slope is 3/1. Then our third step was plug into y minus y1 equals m times x minus x1. Okay, and that's how we can, and the only thing that'd be different if I am, the only thing that would be different if it was a parallel slope is step 2 would be identify the parallel slope, which is just the same value as the given slope. So that's how we can write and how we can identify perpendicular lines and parallel lines just by looking at their equations. It's much stronger than looking at a picture because sometimes our pictures are a little weird. So if we know the slopes, then we can be confident in, if we know the slopes, then we can be confident in saying whether they are perpendicular, parallel, or neither. So thank you for watching this video, and I hope you have a great evening.